We will now be simulating a simple circuit using LTspice from Analog Devices. If you go to this official website, you can download the installation file appropriate to your operating system. I have already downloaded and installed LTspice, and it looks like this. The first thing we have to do is start a new schematic. Then let us grab some components. Let's start with this resistor. In LTspice, by default, the upper side is the positive terminal. The lower side is the negative terminal. For this particular example, I want the positive terminal on the left-hand side. The reason being is that I will be placing the DC voltage source on the left-hand side of the circuit. You can rotate the component by pressing the combination of Control and R keys. What it will do is that it will rotate the component 90 degrees clockwise. So now the positive terminal is on the right-hand side. I will have to rotate it further. So altogether, we have rotated the component by 270 degrees. Now the left-hand side is the positive terminal. Let us grab a voltage source. You can just press the escape key because we only need one voltage source. Then we can wire our components together by pressing this. Well, the good thing with the LTspice is that you can go through the component, and it is smart enough to recognize that you are not trying to short out the component. We will form a closed loop by going back to the negative terminal of the voltage source. Okay, now we will also need a ground. You can just place it here. You can connect this ground circuit. Now, let us assign values for our components. If we right-click on B1 and say we want 5 volts, we can leave the series resistance blank. So what it meant is that it is a DC voltage source with a 0 ohm series resistance, or in other words, it is an ideal voltage source. Of course, in practical circuits, a voltage source has a series resistance. But for this simulation, we will just assume that it is an ideal voltage source. We will leave the series resistance still blank, which means it is 0 resistance. So let's just press OK. For the resistor, right click, then we can just say 10 ohms. The unit is there, it is understood to be in ohms. We will just leave it as 10 ohms. Now, let us configure our simulation by pressing on this configure analysis. We will be using the transient analysis, and transient analysis requires a stop time. This is a voltage source, a DC voltage source, and a resistor. So our circuit is not time dependent. So arbitrarily, we can put any time here, say 1 second. And this one, I can put it somewhere here. Doesn't really matter where you put it. Now, Let us run the simulation. You can see a probe window appears. This probe window is just like an oscilloscope, wherein you can see the actual waveform. Let's try to probe the circuit. Let's say at this point. As you can see, at this point, we have 5 volts, a constant voltage. And this is actually the voltage available from our DC voltage source, 5 volts. The the right-hand side of the resistor is actually connected to the ground, so it is 0 volts. What we might be interested with is what is the actual current flowing through R1. So if I just double click here, it will show you 500 milliampere. Let us verify that. By using Ohm's law, 5 volts divided by 10 ohms will give you 0.5 amperes, which is 500 milliamperes. So that is correct. Another thing I would like to show you is what if we want to somehow show the current through R1. We can do that by just right clicking anywhere here and drop, then off the data label. Let's say I want to put it here. Now we can right click on that, and now we can choose the expression we want. In this case, I want IR1, the current flowing through resistor 1. Just say okay. And yes, it is 500 milliampere. Now let us do another simulation. Let us close this probe window. Let me maximize this one. Now, let us reconfigure the simulation. Press this configure analysis again. And this time, we'll be using the DC operating point. As you can see, there's not much to configure with this simulation. So just press OK, and again, place it somewhere here. Let's run the simulation. Now, let's see. The current flowing through R1 is 0.5 ampere, as what we have found earlier. If you remember, when we started drawing our circuit, we intentionally orient R1 in such a way that the positive terminal of R1 is on the left-hand side. And as what we have said, the reason being is that our voltage source is on the left-hand side. If, however, what we have done is place the resistor and just rotate it by 90 degrees in such a way that the positive terminal is on the right-hand side, and then do the simulation as what we have done, what you will find out is that the current flowing through R1 is negative. So it is numerically correct, but you know, the sign is wrong because it should be positive. The current flowing through R1 should be positive 0.5 ampere. And that's why it is important that you orient the component correctly. Now, another thing to look at is the current flowing through the voltage source V1 is negative 0.5 ampere. Well, in LTspice, by convention, when a current enters the negative terminal of the voltage source, it is negative. If the current enters the positive terminal of the voltage source, it is positive. In our case, the current flows from the positive terminal of the voltage source, goes through the resistor R1, goes through this wire and come back and enters the negative terminal of the voltage source V1. So indeed, it is negative. And if you remember, it agrees with the passive sign convention. LTspice follows passive sign convention, which is almost the standard in any circuit analysis, electric circuit analysis. Another thing I forgot to point out is that some of you may argue that, wait, resistor has no polarity. And that is true. I mean, it, in practical circuit, you can orient the resistor in any way you want without worrying for polarities, like a diode has polarity, but not a resistor. But for simulation, I mean, for LTspice, even other spice software, component has polarities, and for the reason you have seen, I mean, if you did not orient it properly, you will get a, a negative or not the sign you wanted. So for the simulation, I think we have done what we want for this video. The next part will be hooking up the circuit on a breadboard using actual components, DC power supply, and we will also show how to measure current using a multimeter and also how to measure voltages across components like R1 and the DC voltage source. So for the simulation part, it's done for now.